Find the standard form of the equation of the parabola that has a vertex at -2, -4, and contains the points -6, 0, and 2, 0. Okay, let's start off with a quick sketch of the information they give us. -2 and -4. So here we have our vertex, and it goes to the point 2, 0, and -6, 0. So we can kind of sketch our graph now. Okay, this standard form, this is an x opens up or down, so this would be x minus h quantity squared equals 4p y minus k. That would be the standard form we're trying to find. And p is the distance from the center, sorry, the vertex, to the focus. Now, I don't actually know where the focus is. It's an assumption that the focus is at the x-axis, and then these points are actually the endpoints of the LR, the latus rectum, but we actually don't know that for sure. Just because it goes through those points doesn't mean that that's the location of the focus. So the focus is just somewhere along the axis of symmetry. Where is it? We need to figure that out. The easiest thing to do is to take a point like this one and plug in, let's see, I'm getting a little bit ahead of myself. Let's go to the vertex. But anyway, we're going to plug in this point in for the x and y. But before we do, let's get as much into this equation as we can. It'll be x plus 2 quantity squared equals 4p times y plus 4. That's applying the vertex to the h and k. And now plugging in the 2, 0 will leave us an equation that just has p. That's what we want. So 4 squared equals 4p times 4. That's 16 equals 16p. So we have p equals 1. Since we know p equals 1, we can now put 1 in for p, and that would just be 4, and write our final answer, x plus 2 quantity squared equals 4 times y plus 4. So we now know that it's up 1. That's where the focus is. That would be the latus rectum. These just happen to be x-intercepts. They didn't really help us directly, but they sure helped us indirectly find p. All right, I hope this helps.